OMG, finally the last activity and then the talk to talk. Like I said, very long lesson, split it up over 2 days at least. Powers less than one or numbers less than one, that means if we get a negative number as well, what's going to happen? And what happens if we have a zero? That's going to be interesting, okay? So let's consider each part of the parts. Right here, all they're saying, of course, we know 4 divided by 4 is just 1. But if we look at it from an exponential standpoint, this is going to be our zero property. Okay? That means 4 is to the power 1 and 4 is to the power 1. If we do the subtracting like we did in the quotient rule, 1 minus 1 is 0. So this would be 4 to the 0, which gives me 1. Same thing for the other two. 1 minus 1 is 0. So this would be 9 to the power 0 is also 1. And finally, 1 minus 1, that is 25 to the power 0, which is also 1. This is extremely important because it's kind of funny to think about it. But a lot of us don't know that the power of the 0 is always 1. You can put whatever number you want. Look, I can type in a big number. Oh, I don't know why I put parentheses right there. And if I raise that to the power of 0, that gives me 1. Very, very interesting. Okay? So, without simplifying, you know, I already did it for you. Next, if we do the quotient rule of powers, leave your answer as a power. What do we notice? That it is always 1. 0 power gives me a value of 1. Okay? Very important. That was a quick page. Let's keep rocking and rolling. Grabbing the correct page. What are we looking at next? Let's determine how to use the powers to represent numbers less than 1. Oh my gosh, what's going to happen? So, it looks like we're going to get 1, and we're going to multiply it by 10 to give me 10. What is this as a value? 10 to the power 1. If I multiply this by a 10, this also gives me 100. We know 10 times 10 is 100, which is 10 to the power of 2. And then one more, we can see the pattern, 10 to the power of 3, which is 10 times 10 times 10, which is 1,000. Okay? Very cool. Describe what happens as the exponents of the numbers become greater. Obviously, we can just say that the numbers are just becoming greater. However you want to describe it, that's your own representation of it. But what happens when we start dividing? Very, very interesting. Okay? Very, very interesting. So, this is what we're going to do. If I divide by 10, that gives me 1, which represents 10 to the 0 over 10 to the 1, which gives me 10, 0 minus negative 1, which is 10 negative to the power of negative 1. What the French toast did I just read? Here we go. So if I divide this by 10, I ended up getting 1 over 100, which is just 10 to the 0 over 10 to the 2. If I do this quotient rule, it's 0 minus 2, which gives me 10 to the negative 2. What the heck did we just do? This is going to be very key, so star this up, okay? We can't have negative exponents, which is where it's going to come into play in just a second. If I divide this last one by 10, we'd get 1 over 1,000. We talked about it above. That's 10 to the 3. 1 is going to be 10 to 0 because that's what we talked about on the previous page. This is 10 to the 3. Using the quotient rule, subtracting. 10, 0 minus 3 is 10 negative 3. Oh my gosh, I'm getting scared. I'm just playing. But the numbers are decreasing, and which also means that these decimals are increasing every time that we have a negative value. So all these are decimals, okay? These are decimal values. We can't even say that. These are decimals. Okay. What's next? Pause the video if you need to. I promise. Pause the video. Okay. Rewrite the sequence. Do we want to do that? Let me see what it looks like real quick. Excuse me. Okay, this is just letting you know we can identify this as a power of 2. Okay, if we identify this as a power of 2, we can see that the 1 is represented by 2 to the 0 going this way. This is 2 to the 1. Going this way is 2 to the 2. Going this way is 2 to the 3. If I go that way, we're going negatively. 2 to the negative 1, 2 to the negative 2, and then 2 to the negative 3. Opposite ends of the spectrum. Very cool, especially with B, okay? Looking at this good stuff right here. Number 7, little star. And make sure that they're not going to confuse us. We can leave it as a decimal, but we just want to make sure we can write this. 0 minus 3 gives me 10 to the negative 3. 0 minus 5 gives me 10 to the negative 5. 0 minus 4 gives me 10 to the negative 4. Scary, scary. I like this stuff because the love of my life is in the medical field. For all my nurses and doctors of the future, this is where we're learning medical math. Of course, we're not going to go into detail, but when you're doing medicine, you do have to know your place values and all that good stuff. Okay? Doing this really fast. We can see this is negative 3. So that means this is a 1 over 10 to the 3. Since this is 10 to the 6, going this is going to be 10 to the negative 6. Going backwards, 9. It's going to be 1 over 10 to the 9. 12, all these are negatives, so we're going to do 10 to the negative 12. And then over here, the make it a little bit easier. The exponents represent the amount of zeros. So 1 over 1, 6 zeros. You can even count right here. There's 9 zeros. Right here, 12 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Beautiful. Very intriguing. Don't pay too much attention to this. This is not on the STAR test. But of course, my medical people, if you want to deep dive into this, that's exactly what you're going to be looking at in the near future. Pause it if you need to. How many pages? Oh my God, last page of 1.6. Thank you, Lord. We're about to get scared in the talk to talk. But let's check this out. Rewrite this as a positive exponent. So this is where we're talking about negative rule. Okay, so I'm going to make sure we say this is the negative rule. We can't have negatives. So this turns into an automatic fraction. Okay, so how do we approach this? How can we think of a way to ensure that we remember, okay, all I got to do is when there's a fraction, I got to do it the opposite way. It's kind of like doing a perpendicular type of line where we're just flipping these numbers, the negative inverse. I like that word. We're kind of doing the negative inverse with the exponents. Don't quote me on that 100%, but that's somewhat of what we're doing. This is how it's going to go. 8 to the negative 4, make it a fraction, 1 over 8 to the positive 4. Why is this true? Little star right here, because 1 is basically 8 to the 0 over 8 to the 4. 0 minus 4 gives me negative 4. Okay? Real quick. 1 over 5 to the positive 6. Real quick. 1 over 7 to the 5th. Last one. 1 over 4 to the 2. And 3 to the 3. Okay? Very quick, very straightforward. I want to go into more detail like this, but even then, when we have a fraction and it's negative, that means it'll turn positive by making it a regular number, okay? So it's going to be in this next table, I swear. Watch. Exactly what I was about to say. So if we have a fraction with a negative number, that means that this is coming to the numerator. So this is now 3 to the positive 2. They want you to evaluate this. This is just 3 times 3, which is just 9. Moving this up also, 4 to the power of 2. 4 to the power of 2 is 16. Double check with your calculator if you don't believe me. It's putting this to the numerator because we don't like negatives. 5 to the power of 2. That gives me 25. I like that they did this example for us. This is like number 9. Doing the negative inverse, we get 1 over 3 to the power of 2, which is just 1 over 9. Doing the negative inverse, 1 over 5 to the 2, which is just 1 over 25. I love this table a lot. Definitely star it. Do what you got to do. Star it up. The negative rule is very, very intense. Okay. Describe how to rewrite any expressions with negative numbers. We talked about the negative inverse. Describe how to rewrite any expression with negative exponent in the denominator. We're doing the negative inverse. All right. That's a 12-minute video, probably the longest. I'm going to put a little video on the talk to talk. Probably going to do the first page only. And we do probably want you to try the rest on your own. Okay? Y'all have a great day.